Welcome back, learners, to the fourth lesson of factorization. Right now we're going to have a look at the second type of factorization. So in the previous three lessons we focused on common factor factorization. Now we're going to have a look at the second type. What's very important as we go along, it's important that you always start with common factor factorization first. And the next step after that is you can have a look and see if they ask you to factorize, or if you're having to simplify an expression, are you factorizing using the difference of two squares? This is the second type of factorization. So similar to how I introduced the previous lesson, we'll have a look at how do we start with simplifying, getting to the answer, and then we'll work back from the answer, getting back to the kind of question. So the second type of factorization, the difference of two squares, and just in terms of making it a bit easier, we're going to call that dots, difference of two squares. So when it comes to factorization using the difference of two squares, this is where it originates. So if I'm simplifying, this is not factorizing it, I'm just at the point of simplifying to explain the concept to you. If we had x plus 1, x minus 1, and I need to multiply this out, what am I going to do? I take the first term in this bracket multiplied by the first term in the second bracket, and then the first term multiplied by the last term. And then I'll take the second term and I'll do the same thing, I'll multiply by the first term and the last term. So it's x multiplied by x, is an invisible 1 and 1 there, so that's x squared. X multiplied by negative 1, so it's a positive times a negative is a negative, negative x, I don't have to write negative 1x. And then 1 times x, similarly it's just plus x, there's an invisible 1 there. And then I've got a positive x multiplied by positive 1 multiplied by negative 1, that's negative 1 over there. So now I've got x squared, negative x plus x, that cancels out, so I'm left with x squared minus 1. So if I was to be asked, how do I now factorize x squared minus 1? What it means is I need to come back to that point over there. So let's have a look at how we factorize it. So the first thing that we need to be able to do is we need to be able to identify and difference of two squares. So we need to identify the difference of two squares, dots. So we've got here x squared minus 1. So how do I identify when it's going to be difference of two squares? There's three things we're going to look at. The first thing is, number one, is that there are two terms. So that's the first thing. There are two terms. So there's a term and there's a term. Now sometimes you'll see the terms can be individual variables like this, but this could also be a term, x minus 2 squared minus 4. So that there is also one term. So just be careful, that's one term and that's one term. The second thing, which is easy to identify, is that there is a negative in the middle. There's always a negative in the middle. And then the third important characteristic is that basically both terms are perfect squares. Both terms. So term 1 and term 2 are both perfect squares. What do we mean by that? What we mean is that if we square root this here, so if I say the square root of x squared, my answer in this case is going to be x. The square root of 1 is equal to 1. So I'm not getting an irrational number as my answer. My answer is a rational number. So let's have a look at a couple of examples, and then either in this exercise or the next exercise we're going to do some exercises. So it's important that before you move on, you need to know how to identify difference of two squares. So there's 3 points to remember. Number one is there must be two terms, there's a negative in the middle, and both terms are perfect squares. So let's have a look at a couple of examples. Example 1. 9x squared minus 25. Every time we have a look at an example, the first thing that we're going to ask ourselves is it possible for us to do common factors? So in this case, the highest common factor is 1, so we're not going to worry about that. So then we have to ask ourselves, according to the 3 criteria of dots, difference of 2 squares, what is that 3 criteria? There must be 2 terms. There must be a negative in the middle, and both terms must be perfect squares. Both terms must be perfect squares. So we've identified it. There are 2 terms, there's a negative in the middle, and both terms are perfect squares. The next part is we now have to actually do the sum. So when we do the sum, we're going to follow the following steps. We have 2 brackets. In this case, there's a positive and a negative, not just a negative. And then we take the square root of the first term. So the square root of 9x squared, the square root of 9 is 3, and the square root of x squared is x. So the 3x goes over there and over there. And then we take the square root of 25, it goes over there and there. So the square root of 25 is 5. So how do we know that's correct? 3x times 3x gives us 9x squared. 5 multiplied by 5 is 25. If we were to simplify this and multiply this out, you'll see that the middle term, which is going to be 15x, is going to be lost. Not lost, but it's going to cancel out. So let's just do that quickly. We'll do it for this example, but not for all the examples. When it comes to factorization, you can always check your answers to see if you're correct. So you've got 3x times 3x, that gives us. So this would be if they had said you need to simplify this particular expression. So it's 3x times 3x is 9x squared. 3x multiplied by negative 5 gives us negative 15x. Then you've got positive 5 multiplied by 3x, that gives us positive 15x. And then positive 5 multiplied by negative 5, it gives us negative 25. And my final answer is going to be 9x squared. You'll see that the 15x, the negative 15x plus 15x cancels out, and I'm left there. I'm back to my answer, which is 9x squared minus 25. Let's have a look at another example. Example 2. 1 over 81 minus x squared. I know that we don't like fractions, but sometimes we have to just take it one step at a time. So we follow the 3 rules, the 3 things around is this difference of 2 squares. The first thing, there are 2 terms, there's a negative in the middle, and both are perfect squares. Because if you try to work out the square root of 1 over 81, and this is maybe just a bit of revision, what we could do there is we could break that up between the square root of 1 over the square root of 81. And then that will give us 1 over 9. So if you see a fraction, this is basically all you're going to do when it comes to dots. Because we need to find the square root of 1 over 81. So in this case it's 1 over 9. So when I do the answers, what do? First brackets, brackets. Example 2. So we're going to say plus minus, and then the square root of 1 over 81, as we've seen over here, is 1 over 9. So we put the 1 over 9 there, 1 over 9 over here, and the square root of x squared is going to be x, because x times x gives us x squared, and that's my answer. Let's just do 1 or 2 more examples. Example 3. X minus 3 squared minus 16. Whenever you see this situation over here, you've got x minus 3 squared. This is a perfect square, because if you take x minus 3 squared and you find the square root of x minus 3 squared, that is going to give you x minus 3. Why? Because you've got 2 divided by 2 is equal to 1. Remember, according to the laws of surds, so that would basically be my answer. So that is a perfect square. That's a perfect square, and I have a negative in the middle. So that means if I'm dealing with brackets, what we'll do is we'll first use square brackets, and the square brackets later on will be converted to round brackets. So we're going to put a plus and a minus there, just like we normally do. The square root of x minus 3 squared is basically just x minus 3. So I can have x minus 3 and x minus 3 over here. The square root of 16 is 4 and 4. Okay. The reason why I did a square bracket is sometimes what some people would do is that basically just put that in brackets over there. So we're taking it as is and putting it in there, but because it's a positive sign, it's actually not necessary for the square brackets. So my final answer will be x minus 3 plus 4. So if I was to get rid of the brackets, that's basically how it would look. And so my final answer will be x plus 1, x minus 7. Please do take note that sometimes there's different ways to get to the answer, just as long as we're not breaking any laws. So I could have either done this step, or I could have skipped this first step over here. Okay, thanks guys. In the next exercise, in the next lesson, we're going to basically do an exercise. Thank you for listening.